Hi, you are watching Biochemistry Simplified with Dr. Honors. So in today's tutorial, we are looking at glycolysis, galactose metabolism, and fructose metabolism. Glucose is the main source of the energy, but the cell can also use galactose and fructose as the source of energy. So if we use galactose as the source of energy, that refers to the galactose metabolism. If we use fructose as the source of energy, that refers to as fructose metabolism. And if we use glucose as the source of energy, that is glycolysis. So we are starting with glycolysis. So glycolysis involves the utilization of glucose. So it converts glucose into 2 mole of pyruvate, that is from 6 carbon glucose to 2 mole of 3 carbon of pyruvate. And it is refers to as the Embden-Mayer-Pannas pathway. So these other names are the names of the scientists who discovered glycolysis. And the site for glycolysis is the cytosol of the cell. So it can occur or take place in the presence of oxygen and in the absence of oxygen, that is aerobically and anaerobically. So in the presence of oxygen, pyruvate enters into the Krebs cycle and converted into 32 molecules of ATP in the electron transport chain. So in the absence of oxygen, the pyruvate is converted to lactate by the enzyme lactate dehydrogenase. This glycolysis involves 10 enzymatic reaction, and this 10 enzymatic reaction is divided into preparative phase, which is also known as the investment phase, the cleavage phase, and the payoff phase. Alright, let's start with the steps. Step 1 is the conversion of glucose to glucose-6-phosphate by the enzyme hexokinase or glucokinase. We use hexokinase most of the time because hexokinase is present in most or cell and it has high affinity for glucose. While glucose has low affinity for glucose and only present in the liver. In step 1, there is phosphorylation reaction, that is, there is addition of ATP to glucose to give us glucose-6-phosphate. So in step 2, glucose-6-phosphate is converted to fructose-6-phosphate. So there is isomerization reaction by the enzyme phosphoglucose isomerase. In step 3, fructose-6-phosphate is converted to fructo-1C-bisphosphate by the enzyme phosphofructokinase 1. Here there is addition of another phosphate group. So ATP is added to give ADP. The reaction here is referred to as phosphorylation reaction. So the phosphofructokinase 1 is referred to as the rate limiting step. The step from fructose-6-phosphate to the 1C-bisphosphate is the rate limiting step and it is irreversible. So step 1 is irreversible, step 2 is irreversible, and step 10 it is irreversible. Alright. So the next step, which is step 4, is the conversion of fructo-1C-bisphosphate to dihydroxystone phosphate and glycerol phosphate by the enzyme aldolase. So here there is cleavage reaction. The dihydroxystone phosphate is irreversibly converted to glycerol phosphate. So we have 2 mole of glycerol phosphate. So these 2 mole of glycerol phosphate, they both proceed to give 2 mole of pyruvate. Alright. So step 6, glycerol phosphate is converted to 1,3-bisphosphoglycerate by the enzyme glycerol phosphate dehydrogenase. So the reaction here is phosphorylation and dehydrogenation. And NAD plus is converted to NADH. So 1,3-bisphosphoglycerate is converted to 3-phosphoglycerate by the enzyme phosphoglycerate kinase. So here there is generation of 2 ATP. So in step 8, 3-phosphoglycerate is converted to 2-phosphoglycerate by the enzyme phosphoglycerate mutase. So any mutase enzyme that is, there is change in the position of the phosphate group. Hope you understand that. But for kinase, that is, there is phosphorylation, that is, there is addition of a phosphate group. So the phosphoglycerate is converted to 2-phosphoglycerate, that is phosphoglycerate mutase. 2-phosphoglycerate is converted to phosphoenol pyruvate by the enzyme enolase, which involves the removal of water. So there is dehydration reaction here. And the last step, which is step 10, is the conversion of phosphoenol pyruvate to pyruvate, and ATP is also formed. So step 1, step 3, and step 10 are irreversible. They are the rate limiting step. But step 3, the phosphokinase 1, is the main rate limiting step of glycolysis. So in the investment phase, we use 2 ATP. That is, in step 1 and step 3, we use 2 mole of ATP. But in payoff phase, we generate 10 ATP. How? Let's see. In step 6, conversion of glycosidative phosphate to 1-bisoglycerate, we generate 2 mole of NADH. And 1 NADH equals to 3 ATP. So that is 3 times 2, that is 6 ATP. With the 2 ATP that we generate in step 7, conversion of 1-bisoglycerate to 3-phosphoglycerate, and step 10, conversion of phosphoenol pyruvate to pyruvate, making 4 ATP, plus the 6 ATP, making 10 ATP. So we generate 10 ATP in the payoff phase, and we use 2 ATP in the investment phase. Can you see? We invest 2 ATP, we are now generating 10 ATP. So the net ATP now will not be the ATP generated in the payoff phase and the ATP generated in the investment phase. That is 10 minus 2, which gives us 8 net ATP. All right. So now let's look at galactose metabolism. In case the cell doesn't see glucose to use as a source of energy, and there's galactose, then it undergoes galactose metabolism. So galactose is converted to galactose 1-phosphate by the enzyme galactokinase. Galactose 1-phosphate is converted to glucose 1-phosphate. Then glucose 1-phosphate is converted to glucose 6-phosphate by the enzyme phosphoglucomutase. So this glucose 6-phosphate then migrate to glycolysis at the second step and go down until pyruvate is produced. So for the fructose metabolism, it starts with fructose to fructose 1-phosphate by the enzyme fructokinase. So this involves addition of ATP. Any kinase enzyme undergoes phosphorylation reaction. Hope you understand that. Then fructose 1-phosphate is cleaved by the enzyme aldolase B to dihydroacetone phosphate and glyceraldehyde. So dihydroacetone phosphate is converted to glyceraldehyde phosphate by the enzyme triphosphate isomerase. So they are both isomers of each other. So the action that occurs there is isomerization, and the conversion of glyceraldehyde to glyceraldehyde phosphate is addition of a phosphate group, that is phosphorylation reaction, and there will be kinase enzyme. Hope you understand that. So the enzyme there is triose kinase from glyceraldehyde to glyceraldehyde phosphate. So glyceraldehyde phosphate, which is formed now, migrate to step 6 of the glycolysis and go down until pyruvate is formed. All right. Now let's look at the mnemonics for glycolysis. So for glycolysis, it is good God fetched fish, great days by 3 p.m. and 2 p.m. and pay price. So the good is the glucose, God is the glucose 6-phosphate, fetched is fructose 6-phosphate, fish is fructose 1-bisphosphate, great is glyceraldehyde 3-phosphate, days is dihydroxyacetone phosphate, by is 1-bisphosphoglycerate, 3 p.m. is 3-phosphoglycerate, 2 p.m. is 2-phosphoglycerate, P is phosphoenol pyruvate, and price is pyruvate. So glucose to 2 mole of pyruvate is glycolysis. Galactose to 2 mole of pyruvate is galactose metabolism. Fructose to 2 mole of pyruvate is fructose metabolism.